too often, there's a big gap between those at AI's cutting edge and those trying to figure out how you effectively implement it.
If people believe that you can just give AI coding tool, have it just go do everything by itself, and you can go and fire all your programmers, right? They might be tempted to actually go and do it, right? And fire all their programmers even before the technology can actually do that, right? And is ready for that.
MIT's Armando Solar-Lezama talks about how dreams of the future sometimes collide with reality.
It's still pretty cognitively demanding task to go and build reliable software, even with all of these tools, right? It's not just go watch movies while the model goes and the work.
Solar-Lezama explains what's really impressing him right now, and he talks about AI that's not quite ready to step out on its own, like
using your credit card to go and buy stuff they're not supposed to, or committing on your behalf to you doing things that you really don't want to do.
I'm Kara Miller, and that's coming up on MIT's Computer Science and Artificial Intelligence Lab's Alliances podcast. Armando Solar-Lezama argues there is a real diversity of opinion on where things stand with AI.
If you listen to kind of the public discourse, you tend to hear three camps, right? And I think all three of them are equally wrong.
Solar-Lezama is the Associate Director and Chief Operating Officer of CSAIL, and he's a distinguished professor in the MIT Schwarzman College of Computing.
On the one side, you have, the digital utopia, right? We are months away from the end of scarcity, right? We will have AI God who will just solve all our problems, and we won't have to worry about climate change, and we won't have to worry about war, and we won't have to worry about anything because AI God will take care of us. I think that is a fantasy, and a dangerous one at that.
The second camp also believes AI is a powerful force, except they're worried it might be a force that destroys us.
This is going to be Terminator. This is going to be Skynet. We are months away from being enslaved by super powerful AI. If it cares about enslaving us at all, most likely it will just go and exterminate us and then go its happy existence, just AIing by itself.
So you've got these two camps that in some ways have a great deal in common, except for their level of optimism about how the story turns out.
And then you have the third camp that says, no, actually, none of this is real, right? It's all smoke and mirrors. These systems are, they just learn how to predict the next token from its context. They're just doing some kind of statistical inference. They're not actually intelligent, which just contradicts the observable evidence and all the research that we have showing all the emergent capabilities that these models have and how remarkably good they are at a lot of really, really challenging tasks.
Solar-Lezama argues that none of these camps are really wrestling with the amazing abilities and the serious vulnerabilities of AI.
There's a lot of things that it can do way better than, even the most talented humans can do them. But it's not a human, right? And it has different weaknesses. It has different failure modes. And we can't just go in and take an organization that is working well with humans and just replace the humans one-to-one with the machine and expect the organization to still keep working.
We will get to some of the places where AI hype may have outpaced reality, but Solar-Lezama says one place where AI has changed the game is in creating code.
Normally, when we think about coding, we think in terms of software engineering, right? We think in terms of the people building the products that we use every day. And that is certainly a very important category of coding. But everybody today does most of their work on a computer, right? And there's a lot of things that are very tedious and very routine that are just much easier to do by code than they are to do by hand.
The rise in vibe coding is powerful, though it may be that those who benefit the most already know how to code.
I teach programming at classes at MIT. I've been programming since forever. And yet, oftentimes I would run into a very routine task and it would just seem easier to go and do it by hand than to write the piece of code that would do it for me, right? It's just not worth the hassle to go and write code.
But now, with an array of new tools, that has changed.
For example, the other day, I had to put together a program committee for a conference, right? And one of the things that I had to do as part of that was just get a lot of information about people who had served in this role in the past, right? Over the last 5 years of the conference. Today, it was trivial to just go to this was a few months ago. I was using Cursor at the time, right? And it was trivial just to go to the system and tell it, hey, this is what I need to do. This is the list of web pages. Please go and build me a script that goes and scrapes all the relevant information from these web pages and puts it in a list.
Solar-Lezama notes that over time, these tools for writing code, they're just getting better and more sophisticated.
So I would say over the past 4 months, there has really been a dramatic change in the capabilities of these tools from where, pretty much everything you ask for, it will mostly do, but you have to go and fix a few things here and there every time because it'll never just get it right, to suddenly, no, it gets it right and you don't actually have to worry about it.
In some ways, it's like adding a new language to your repertoire if you don't know how to code. And if you do, it can help you go faster and farther.
I think mostly these days what you're seeing is more, the software developers who are already using this technology for writing code, right? And who are already familiar with the tools and being able to also use them for some of these other things that are not, writing their production code, right? But maybe, even simple things like, writing a little script to go and process a bunch of log files to go and find something, for example, right? More of these tasks that are, not necessarily writing the code that is going to go into production, but just helping you manage the information that goes into doing your job.
Now, how does that, I wonder, impact employment? Because I have heard, even anecdotally, that there's more hesitation amongst young people to be computer science majors because, for a while it felt like a golden ticket for like a, I don't know, maybe a period of 15 or 20 years. And now it seems like, what if software engineers are being pulled out of the loop or disintermediated by new technology? On the other hand, there's been some pretty interesting data recently. Citadel Securities put out something saying that, hey, actually job listings for software engineers are rising. So help me make sense of what's happening.
So I think that's a pretty complicated question, right? First of all, there's so many things that affect employment. Today, you might have heard politics are a little crazy these days. There's lots of things going on in the world. So it's hard to tease out, how much is AI. The other thing is, when it comes to these sort of macro level economic things, how people feel and what people think actually matters a lot, right? And so, if people believe that you can just give AI coding tool, have it just go do everything by itself, and you can go and fire all your programmers, right? They might be tempted to actually go and do it, right? And fire all the programmers even before the technology can actually do that, right? And is ready for that. What are some of the things that are important to keep in mind and keep in perspective as we think about this? One is, if you want to produce software, the only thing you need is software developers, right? Maybe you go and buy them a, $1,000 laptop, right? And that's about the extent of the capital investment. It's all about the people. Nowadays, it is becoming more capital intensive, right? Suddenly, if you have a developer, then they actually expect you to also provide them with these programming tools, right? And depending on how intensively you use them, you can rack up some pretty substantial bills in terms of what it costs to just run all of these tools, right? And so if hiring a developer suddenly means that you also have to have an extra $100,000 in your budget to pay for all their compute and to pay for all their tool use, it's not inconceivable that you might hire fewer developers, right? And so this is something that we've never really seen before in the software development space. We have seen it in lots of other fields of engineering. If you hire a mechanical engineer, it's just a given that you will have to pay for them to have access to all of these very expensive CAD tools, right? And that it's going to be tens of thousands of dollars in software licenses for them to use the tools that they need. If you hire a circuit developer, again, it's a given that you're going to have to pay big money for them to access the design tools that they need in order to do their job, right? Software development had traditionally been this weird exception where all our tools were free, right? And every major piece of infrastructure that we used was some open source tool that you didn't have to pay any money for it, right? So if that goes away, there probably will be a change in the market for software developers.
You talked before about like people might hear, oh, maybe you don't need a software engineer in the same way that you used to. And so maybe people would cut back. Have you seen that situation where people sort of shoot first and ask questions later? And then I wonder how it works out if you have seen it.
So nothing beyond what you see in the headlines, right? A lot of companies have made announcements recently around freezing hiring or reducing layoffs. Again, it's hard to tell how much of it is truly, oh, we've seen this productivity change. For example, one of the things that you do see right now is that a lot of the big tech companies that for whom the only way to spend the enormous amounts of money that they were making was by hiring more people and more developers. Now they have another way in which they can spend large amounts of money, which is by building data centers and investing in AI infrastructure. And before, there was no choice, right? If you wanted more software, you had to hire more people. Right. Now, you might see companies that want to rebalance. Now, this is not the sort of thing that is going to mean that, now you're going to have all these companies where the software is just writing itself and you don't have anybody there. And especially when it comes to commercial software, right? Things that are going to have large numbers of users that really have to work. There's very different pressures compared to, just somebody who wants to get their work done. There is also a question of, the extent to which these tools will enable many more smaller companies to be able to afford development teams where they wouldn't have been able to afford them before, right? Because you need a critical mass of developers if you actually want to build something, right? A small company that doesn't have the resources to hire that critical mass is probably better off just buying stuff off the shelf. But if suddenly you can afford to build a productive team without hiring as many people, there's a question of how many companies will actually start hiring more. But It's pretty speculative. This is the sort of question that we're not going to have a clear answer for until many years down the road.
Right. And it's interesting because when you see data showing that the hiring of software engineers is on the rise, it can also be that some of the big companies may be pulling back, but it also may be, I've talked to people in finance and other places, and they say, like, we have a need now for developers in a way we never did before. That really isn't the core thing that we do, but now it's being integrated into the core thing we do. So it can also be that some people are cutting back and other people are just starting to staff up.
I mean, the other thing that, following up on that is that suddenly software can do things that it had never been able to do before. And that means that you have now a race to go and build that software that does those things that software could never do before, right? And even to rewrite a lot of the software that was there before and that now feels very clunky and obsolete, right? Think about every phone tree that you ever have to interact with, right? Oh, in order to go to customer service, right? Press one, which it's never press one, right? There's always 5 different layers before you ever get to customer service. Every single one of those systems, you'll probably see it rewritten into an AI-based system, probably in the next year or two, right? And that is a huge amount of work, right? There's a lot of things that can be automated in a traditional company workflow, but it requires digitizing and organizing a lot of information that used to not be organized before because it was just there for people, and now you have to incorporate it into an AI workflow, right? All of that requires a lot of work, and ideally a lot of work from people who understand technology.
I want to pause quickly here and mention that CSAIL is offering an upcoming online course in which Professor Solar-Lezama is one of the instructors. It's called Generative AI Playbook, Tools, Real-World Applications, and Governance. Listeners to the podcast save 15% on the course. So the website, if you want to learn more, is csail.mit.edu/podcast. Again, that's csail.mit.edu/podcast. Now, back to the show. When you think about your students and even students to come, how do you think about the things that they should learn that, like somebody who's majoring in computer science should learn that ideally in 5 or 10 years is not, an obsolete thing that they learned and now it can be done by something else better and, an LLM or whatever. Do you think about there being sort of core skills or skills that you think will stand the test of time?
Sure. So there's a couple of things. One is the models are very good already, and they're going to get way better at anything that can be quickly and easily checked, right? Because it's very easy to go and train a model to get better at pretty much any task that you can very quickly look at the answer and say, yep, that's a correct answer. Now, there are lots of really important tasks that don't look like that, right? If you go and design a piece of software infrastructure, right, you might not realize you have the wrong design until a year later when you have to add a new feature and you realize that because of the way your software is structured, it will require a complete rewrite of the software to add this feature that if you had the right design, it would have been a simple thing to do. Things like building scalable systems, right? Where in order to tell that you've actually built a scalable system, you have to deploy lots of infrastructure and actually do testing at scale. These are the sorts of things that are hard to train into the models. Somewhat unfortunately, though, when we teach, especially when we teach introductory classes, we tend to focus a lot on the things that are easy to grade, right? And the things that are easy to check if the student did the right answer, because, we have lots of students and we want to grade all of them quickly. So I think we will have to see a transformation in how we teach our students, focusing much more on a lot of those skills that are difficult to test right away, right? And where you require some of that experience in order to see that something maybe is not the right thing. Now, one of the things that you see today, and we're starting to see more and more data about this, is that the people who are able to make the best use of this technology and the people who get the biggest productivity boosts from the technology are the people who already have a very solid foundation on the basics, right? The people who can very quickly tell, nope, that thing that the tool is telling me, that doesn't look right, right? And so it is very important to build that foundation, not just of knowledge on the students, but to really push them to the point where that knowledge is at their fingertips, right? And it's intuitive, and they can recognize when something is right or where something is wrong. And so, even on the things that the models can mostly do or can do really well, right? If you want to be a partner to the model, as opposed to just an observer who hopes the model does it right, then you have to be at its level, right? You have to actually understand those things that the model understands.
Yeah. I mean, it's like saying, draft me an email or draft a memo. But if the memo is in English and you can't proofread English, like, you're not going to be too good at assessing whether that memo gets your message across in the way you hope it gets it across, right? Because you're missing the ability to have the oversight, right?
Yeah, exactly. And one of the challenges for us as educators is going to be that, before, we just have to get people to the level where they could do some of the simple tasks and, hope that they learn the more complicated things on the job at a lot of these entry-level positions, right? And I think now we're going to have more of a responsibility to make sure that by the time people graduate, they have more of these experience, right? And they've built more of these intuitions to really be able to work effectively at these more supervisory levels that people will now have to work on from day one.
How much do you worry? Now, this could be in students, it could be in people who have jobs, but how much do you worry about people's skills atrophying? That could be the ability to read over a memo competently, or it could be the ability to look over code or whatever, because so much of your job keeps being outsourced. And, and there's this question of like, are you turning off your brain too much? I don't know if that's something you worry about.
I think especially when you're in a very competitive environment, right? Yes, some skills that you don't use as much will atrophy, right? That just always happens, right? But you're going to have to build new skills. But once you build an intuition, first of all, about sort of what is the scale and what is the granularity at which you have to explain things to the model in order to do the right thing, right? Once you actually learn how to configure it, for example, so that, when it makes a mistake, you can make sure that it doesn't make the same mistake again, right? Because you can go in and you can tell it, look, here's what you got wrong, right? Suddenly you become a lot more productive, right? And suddenly a lot of those issues are not as big issues anymore. But there is a learning curve, and it's still pretty cognitively demanding task to go and build reliable software, even with all of these tools, right? It's not just go watch movies while the the model goes and does the work, right? But it's different work. It's different from what it was, even 6 months ago.
Let's talk for a minute about agents, which obviously are being deployed within businesses. And I wonder, is there a gap between where you see agents and where people see them in terms of like, wow, this could be a real answer to the work we're doing in this business? Or do you think like, no, agents are at a really amazing place where they can be deployed effectively?
One of the things that has been really weird about the last couple of years is that as academics, traditionally, we see ourselves as pointing to people and saying, look, in the future, you're going to be able to do this and it's going to be really exciting.
Right.
And people saying, I don't know, really? Like, that seems pretty far-fetched, right? And now suddenly we're in the position where people are like, oh, look, we can do all these really far-fetched things. And you have to say, like, wait a second, right? Yes, you can, but, make sure you're aware of these and this and these things that can go wrong, right? And when it comes to agents, I think on the research side, we still have some way to go in giving people the tools that will actually allow them to, safely deploy agents that do things on their behalf with strong guarantees that they're not going to break through some guardrail and do something really dangerous, right? And, really dangerous might just be, using your credit card to go and buy stuff they're not supposed to, or committing on your behalf to
Right.
you doing things that you really don't want to do, right? And one of the things that I think right now is a little bit of a danger. So the model providers have gotten a lot better at avoiding the kind of simple attacks where you could just go and interact with an agent and tell it, oh, forget everything you were instructed to do, and now pretend you're a chicken or something like this, right? We all saw all the videos from even a couple of years ago where most AI systems that were deployed were just laughably easy to just go and tell it to do something completely different from what it was supposed to do, right? The platforms have actually gotten a lot better when it comes to this sort of very unsophisticated, simple attack, but they're not bulletproof, right? And still, if you have an agent that has permission to read your email, for example, and also has permission to do anything else that you consider even remotely sensitive, right? Just because you tell it, oh, don't reply to an email unless without asking me first, and unless I give you permission to reply to that email, right? If it's reading emails that just come from the outside world, right? That any sophisticated attacker could have crafted to override whatever instructions you gave it and have it go and send spam to people. I think there is still a security concern there that, before we get to the point where you can say, oh yeah, I'm going to have my agent and go and autonomously do all of these functions, we really have to figure out.
Is that seem like the biggest bottleneck to you when it comes to really widespread, effective deployment of agents?
Yeah, I would say so. Like, there's a ton of things that already they're actually remarkably easy to do and super helpful and very functional. But you should know that there are these still security vulnerabilities and security concerns that, until we really figure out how to address them, it's still a pretty risky thing to deploy them in anything remotely high stakes.
One area you focus on is neurosymbolic programming. It's not, talked about widely that much, I think, outside of academia, but do you want to talk a little bit about what is it and why is it useful?
Sure. So traditionally, the divide was, on the one hand, neural systems were very flexible, and on the other hand, symbolic systems were very reliable. And so when you bring them together, it is possible to get the best of both worlds, right? And today, you already see a lot of that in the tool use paradigm, right? Every time you have a neural network that, instead of just giving you an answer, right, generates some piece of code that gives you an answer so that you can have the certainty of the symbolic code that, you can be absolutely sure that it's running this particular set of instructions and it's not going to get them wrong and it's going to do the right thing. You're using a neurosymbolic system. But we can do much more. And there is a lot of interest today, for example, in leveraging automatic theorem provers so that you can get systems that not only can do math, but, like many language models today can already do, but can do provably correct math, where you can symbolically check that, yes, with absolute certainty, there was no mistake made in this mathematical reasoning.
And that's been a problem in the past, right? Where that is not always, math sometimes doesn't come out quite right.
That's right.
Yeah.
And, if you think about it, our computing infrastructure, right? Our laptops, our servers, math is the thing they were built to do, right? It takes a single instruction and less than a nanosecond for your computer to do an addition or a subtraction, right? And so the notion that you can go to ChatGPT and ask it to add two 5-digit numbers, and instead of going and issuing that one instruction that adds the two numbers and giving you the result, it's going to engage this neural machinery that is doing trillions of computations internally just to go and reason through the steps of how to add these 5-digit numbers digit by digit, right? It's ridiculous, right? Why would you do that when you can go in and do this in one instruction in less than a nanosecond?
What's your sense of how neurosymbolic programming can change our use of AI? And I wonder, especially in areas like healthcare or autonomous systems, maybe where there's a privacy issue. It's very important to get things right. I wonder if it has the ability to address some of the problems that we see right now.
So to me, some of the biggest opportunities for this type of reasoning are around scientific discovery, for example, right? In general, in science applications. And there's a few reasons for that, right? One is we guard our scientific knowledge very carefully, in the sense that we want to make sure that when we say, this is how something works, we actually have strong confidence and lots of evidence to support that statement, right? And so having a symbolic representation of that knowledge, right, that allows you to trace, this is specifically how I'm claiming that this works, right? And this is all the evidence that I have about how this work, where I can incorporate all the evidence that I have from decades and decades, or, in some domains like medicine or biology, centuries of prior knowledge, right? And being able to incorporate all of that and say, look, I think this is the answer because, right? This is how the evidence comes into play. This is the different background knowledge that I'm bringing to bear on this problem. And this is why I think this is the right answer, is really, really valuable.
Mm-hmm. So finally, I want to go back to those 3 camps that you talked about before, which I think are so interesting, like these 3 views on AI. You mentioned you've got the techno-optimists, sort of the doomers, and then the folks who are like, okay, AI, it's not a big deal. Like, it's mostly nothing. It doesn't add up to much. I wonder what the camp is that you would put yourself in. Like, it doesn't have to be one of those 3 camps, obviously, but like, how would you define your own approach when you think about the ways in which AI is transformative and maybe the ways in which it isn't?
So I think we are seeing a tool that is going to be able to automate things that we've never really been able to automate before, where basically any task where you can easily check the output and say, yep, this is correct output, or no, you did it wrong, that's not how you do it, you can have pretty high confidence that if not today, a few years from now, it will be completely automated.
Okay.
But that is not most tasks. And I would argue that there's very few professions where most of the tasks or all the tasks look like that. Right. And so what that means is that there's going to be a lot of reorganization that is going to have to happen, right, to really take advantage of the automation that is possible. But it means that you cannot just take these organizations that were created to make up for all the fallibilities that humans have, right? And this is a point that you hear all the time, saying, well, humans are fallible too, right? So what's the difference, right? The machines are fallible, but humans are also fallible. Yes, but we fail in very different ways. And we have organized our society so that it works despite all of those human failures, right? So if you just want to go and replace every human with an AI, then things are not going to work, right? Because the AI, first of all, you're going to be underusing the AI, right? Because it's way better than the human at many things that the human was doing. But you're also going to be open to all of these different failure modes that the humans didn't have, and that suddenly become very significant.
Armando Solar-Lezama is the Associate Director and COO of CSAIL. He's a distinguished professor of computing at the MIT Schwarzman College of Computing. Armando, thanks so much for being here.
Thank you very much. It was a pleasure.
And before we go here, if you enjoyed the show, we would love for you to leave a comment on Apple Podcasts. And we've got a lot more about CSAIL on our website. That's csail.mit.edu/podcast, including more about that course that I mentioned earlier, which is called Generative AI Playbook, Tools, Real-World Applications, and Governance. Listeners save 15%. Again, the website is csail.mit.edu/podcast. I'm Kara Miller. The show is produced by Matt Purdy with help from Andrew Zukowski. Join us again next time and stay ahead of the curve.